and welcome to my presentation. My name is Ann-Kristin Muhsmann, and today I want to talk about automating multi-organ chip assays and analysis. So, multi-organ chip and microphysiological systems in general are already working quite well. However, there are still some general challenges in handling them. One of the most named would be the manual effort. So if you picture a human which wants to eat at least 3 times a day, you would, for physiological maintenance, you would have to feed or do media changes several times a day. But this is quite a high effort. Same goes for the observation. And with increasing the number of organs and the complexity of the organ combination, the manual effort evolves even. Another point is the interruption of the cell culture conditions. So for most of the interactions, such as media changes and observation, right now you have to take the multi-organ chips out of the incubator and also unplug the pumps, which is stopping the heartbeat. And a point which is, I think, typical to cell culture is that the user and lab dependent variability is still quite high. So this is why I developed an automatic system for culturing multi-organ chip, which is called the HUMIMIC AutoLab. All liquid handling procedures are housed in a sterile safety cabinet to hinder contamination. 2 robotic arms, driven by a high-precision positioning system, allow the chip operation and also the transport of provisioning and cell culture material. In the platform area, the chips are operated and supplied with the temperature and the pulsatile flow. Underneath the chips, there's the microscope, which allows for bright field and fluorescence microscopy and can address each chip. And the whole system wouldn't be a great help in reducing the manual effort if you would have to supply it with new media each day. And this is why there's a storage system for 66 well plate, which can automatically provide the media to the platform area. As the HUMIMIC AutoLab is a quite specialized system for the cultivation of multi-organ chip, there was also need of a dedicated software for that. And the HUMIMIC Lab OS allows for user-friendly and a clear overview of the assay. It allows you to monitor the devices or the robot's status and also the assay's status. You can do the planning of the assay beforehand on your computer, and it also gets checked for feasibility and validation during the process. Then obviously you can operate the HUMIMIC AutoLab with it, and this means the pre-planned assay can be transferred, and the stocking can be also stored in, or the stocking, you get an advice for the stocking, and the information is also stored in the system. And then you have different preparation and cleaning modes to prepare the HUMIMIC AutoLab. Furthermore, it allows you to observe or to analyze the image online, and also to store the images for further analyzation after the assay. So the HUMIMIC AutoLab provides automatic and high throughput chip operation with 24 chips and autonomous operation for 4 days. This under consistent and physiological conditions, such as the heating and the pneumatic pumps. And this results then in the end in high content data with increased reproducibility. So the reproducibility is increased because the settings of all data acquisition are the same, and so they are highly comparable. And furthermore, you also get a lot more data points because you don't have to do the acquisition manually. Now let's have a quick look on the technical specifications or the technical features of the system. Here you can see the platform area. On the left side, the space for the 24 multi-organ chips with temperature control and the flow. And on the right side, the spots for substance mixing and media preparation, and the storage for the cell culture material such as pipette tips. On the right side, there's the robotic arm with a well plate gripper for transport of well plates and pipette tip boxes. And on the left side, there's the robotic arm with the pipette and with a tool for opening the multi-organ chips. Underneath the sterile safety cabinet, there's the customized refrigerator with an automatic extraction system in linear axis, which can take the well plates from the shelf and then provide them via a gate to the platform area where they are taken over by the handling system and the gripper. The microscope, or the integrated microscope, allows for automatic addressing of the chips, and you have the opportunity to choose from 6 objectives and 5 fluorescence filters for a variety of different image options. Now let's have a quick look on what microscopic in-process imaging allows us to do. So, for example, you can do the tracking and the control of the morphology of spheroids. It is also possible to use the fluorescence not just for tracking cells with markers. You can also use it for the tracking of the pH value or the temperature. And you can check the flow in the system as well as the quality of the endothelialization. Those are some of the assays we already transferred from manual to automated culture. And the first one, or one of the first one, was the liver and skin co-culture with substance application. And then we also did a liver and intestine co-culture with substance application, which both used barrier organ, one of them with an air liquid culture, and the other one submerged. Then one of the most recent assays we conducted was a 4-week bone marrow assay, where we had to induce the opportunity to use scaffold-based ceramic models as well as cell sampling from the compartments. Here, a quick overview of the results of the liver and intestine co-culture. Here, one of the main aims was to compare the manual conduction or the manual operation of a culture to the automatic one, and as you can see, the data are highly comparable. You can see a variation or a difference in the glucose consumption of the intestine in between the manual culture and the automatic culture, but this is due to an adapted pipetting scheme in the automatic culture. The bone marrow assay or the analysis of the bone marrow assay is right now ongoing, so I cannot show you data. But I want to show you some of the implemented features. As said, there was a need of automated cell sampling, which also placed the need for the flexible adjustment of the pipetting speeds and also the resuspension while sampling from the chip to be able to take out enough cells for the analysis afterwards. Also, Obviously, with the different heights in the compartment, the media heights of the compartment, we had to use different pipetting heights for liquid sampling. Then let's have a quick view on the workflow of the HUMIMIC or with the HUMIMIC AutoLab. So, for example, you have an objective as you want to do a toxicity assay with the intestine and the liver. Then you take this objective to a computer with a HUMIMIC lab OS, and you plan the assay and save it, and then it gets transferred to the HUMIMIC AutoLab, where the assay is executed automatically. Already during the execution or afterwards follows the evaluation and the interpretation. And I think the main or the most well-known evaluation parameters or results are the image analysis and the lab data. But because of the standardized image acquisition and the acquisition of the lab data, we also see the opportunity to use AI methods or machine learning methods to get even more value out of those data. And it's highly likely that in the future those methods also allow us to simulate and predict the outcome or the layout of the assays with those methods. And also in the future, I think it will be possible to adapt the execution and of the assay, considering the data which you get out of the execution of the assay. So to sum it up, the HUMIMIC AutoLab allows us to increase the redundancy and repeatability of our multi-organ chip assays. We can do high throughput testing while still maintaining high content data. We can finally achieve more physiological maintenance of the multi-organ chips, while at the same time reducing the working hours of the personnel. So I think those points are the ones which pave the way for regulatory acceptance and industry adoption in the future. Yes, so I want to thank all of my co-workers and collaborators, and you as well for your attention. And I'm happy to answer some questions now. Thank you.